Okay, this video is recorded to help my students to understand one of the homework problem from homework 2. The problem says, suppose the memory cells at address 00 through 0D in the machine described in Appendix C contain the following bit patterns. Now, he listed this bit pattern on blackboard. The question you need to be careful. Maybe you read it this way more clear. The first column is address, which is the memory address. The second column is content, which means what stored in this memory address. So the memory address, as the problem says, is from 00 to 0D. So you look at this memory address is from 0001, 02, 03 until to 09. We know since you use hexadecimal after 09 is 0A, right after 9 is A, B, C, D. So from 00 to 0D, those are memory address. So in each memory address, it can store some content. So that in memory address 00, store 1 byte. This 1 byte is 20. You know, each digit is 4 bits, right? 2 digits is 8 bits. 8 bits is 1 byte. So each memory store 1 byte. Now, so the memory 00 with address 00 store the byte 20. In the memory address, memory with address 01 store byte 04. Then in the memory address memory with address 02 store the byte 21. Then in the memory address with address 03 store the byte 01. Okay. Now, what does the question say? Assume that the machine starts with its program counter. The program counter contains containing 00. What bit pattern is in the program counter when the machine halts? Now, basically, he wants to say, now you need to understand that program counter will hold the address of the instruction you will execute next. So that means when the program starts, okay, which means the first instruction will be executed. That instruction address is in the program counter. So it means the program counter contains 00, which means the instruction stored in the memory address 00 will be executed first. Now, pay attention, each instruction you actually have 2 bytes. Okay, so the instruction 1 is stored in the memory address 00. Actual instruction 1, the first instruction have 2 bytes. So actually is from 0001. This 2 bytes, these 2 bytes together is 2004, right? So this actually tells us the first instruction. Now maybe I put it here. The first instruction is 2004. Okay. Now this tells you the second instruction is 2101. Okay. So each every two bytes is 1 instruction, because he said program counter contains 00. That means your program started from address 00, so 01. Now, this program is a little bit easy. He didn't ask what does this program mean. He just asked what bit pattern is in the program counter when the machine halts. That means when this program finishes, right? This program finishes. The last instruction for this program, the last instruction is C000. It's here. This is the last instruction. So this instruction, blah, 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 I will not say. Now, this is the last instruction, is C00. If you look at your Appendix C, what does C00 say? C00 means halt execution. C00 word causes the program execution to stop. So the program execution will stop when this one is finished. Now, but he asked you what bit pattern is in the program counter when the machine halts. Now, I don't exactly remember in your textbook. I believe is when the program counter supposed to contain the instruction address that will be executed next. So, since your instruction will store one after another, right? So the next address will be after D, A, B, C, D, E, F is 0E, okay? So 0E, the next one is 0F. So that means your program counter, which means hold the address of the last instruction. Oh, I forgot to mention, each instruction has 2 bytes, but his address is the address of the first byte. So the first instruction, his address is 00. Second instruction, his address is 02. So that means at the beginning 00 in the program counter, because this instruction will be the next instruction be executed. Okay. So at the end, the last instruction, his address is 0C. Now the program counter will hold the next instruction to be executed. Actually, it's supposed to be 0E. So that for this program, the answer will be 0E. What the bit pattern in the program counter when the machine halts. When the machine halts, which means then when this instruction is executed, but then the program counter will hold the next instruction. So the address will be 0E. Okay, that's supposed to be the answer, because after D is E, right? Now you have other you have other programs in this homework will ask you, what does this program actually do? Then you should just follow what I just explained. You extract out each instruction. Like the first instruction is 2004. Then you go to your Appendix C. You start with 2, means load the register R with the bit pattern XY. So in this case, this means you will load. This means load value 04 into register 0, right? Then for this one, means load value 01 into register 1, right? Because 210001. Now then what does this mean? This means this one is 4012. So this instruction is 4012. Then this instruction means, now I don't remember, so I go to Appendix C. 4 means move the bit pattern found in register R to register S, right? So since this 4 is move, so which means you will move value in register, let's say for which one is which, move from the register R, I mean the first register, to the second register. So you will move from the value in register 1 into register 2. So now, since your register 1 has 01 by this instruction, so you know register 2 also has 01 in it. Okay, so you continue to translate those, then you will know what does this program do. For example, here the next instruction is 5112, because 5112. Now 5 means add, right? So this 5 is add. So you know you will add in the ST to the stored result in R. So this means add values in register 1 and register 2 and store the result in register 1. I just type this so I can have space to type. So since from previous one you will say register 2 has 1, register 1 also has 1, so 1 plus 1 equals 2. You store 2 into register 1. Now register 1 has 2. So in the in other programs for this homework, it will ask you to translate, understand the whole program, what this program do. So what you need to do, you just patiently translate each instruction. Then you go through like a machine execute instruction one by one. Then you should be able to see the result. Okay. Okay. Let me stop to get your feedback. If you have any questions, please give me an email.